We should be good. I got the Peanut song stuck in my head. Why do I have the Peanut song stuck in my head? The world may never know. That information is gone alongside how many licks does it take to get to the center of a Tootsie Pop. Cool. Actually, so we were talking about Typist a lot yesterday, and I started trying to integrate it into my blog just to see what that would look like. Whatchamacallit. So I've got a scaffold application here. It doesn't really use the crate APIs. It uses the CLI, so it just calls out. But successfully able to query a random typist file, and I think we're grabbing the output here too. But the output is an HTML file, so we have to read the file in. Using duct to define these commands. Duct is D-U-C-T. Just makes it really easy to like specify some commands and throw some strings in. I think this might be the first stage of my integration. So I've got a couple of, Saturday serializable types. Got an input and output file, this function that can potentially fail. So we take the input output, we query, so typist query for front matter. We read the standard out, pull that into a Saturday array. Then I pull that value out and put it in metadata. And then we also compile. In this case, we're compiling for HTML. And we're supposed to return that as well from this function. So overall, that works fine. It's not the ideal integration, but the APIs for Typist are somewhat unclear. So I'm not sure, like there's a world here and whatever, and there's all these other things. And if you look at the Typist CLI, like it's not a library, so you can't install it. But the code is licensed as far as I'm aware. And you can click on source or go to the GitHub repo or whatever. And it's got all the source here. So like if you were going to compile, you could go to compile. And this compile file is like 700 lines of Rust. Some of that is like if you're running the server and whatever, feature flagged in and out and whatnot. But it doesn't seem as easy as like pulling in the crate and then running compile on some string. So putting this to the side for a little bit, going with the CLI only approach for that. It should work. I should be able to like at least do a prototype integration here. That will allow me to build Typist documents and then ship them on like my blog or whatever. But long term, I would like to use the crate more directly. But that's not what we're doing today. Let's go into, I don't know, Rust Adventure, Cargo New, Async, Bevy. Yeah. Drag this over to a new desktop. Oh, the other thing that was cool is that the USD, I'm not going to call it really a spec per se, but the USD grammar, which I pulled out of the Python files and turned into this pest file, is kind of like released. It's not really released per se, it's like preview. But all the code in this zip file is Apache licensed, so I'm good to start playing with it. And they just throw this basically into a peg parser. I'm not a huge fan of peg parsing. I find that it gives you output that is like not well typed. in the sense that like you don't know how many things are supposed to be in specific areas, etc., etc. I've used Pest before. I've done some like comparisons and demos and stuff. I think I might have that repo up on the Rust Adventure org. I was gonna do a video on like a bunch of different parsing tools at one point. I don't remember if I uploaded this code or if it's like sitting on my desktop somewhere. It looks like it might be sitting on my desktop somewhere, so maybe I should find it and upload it. But basically, like Pest is fine. It's not bad. It just gives you, for example, do we have a little piece of code here? Yeah, we have a little piece of code here. Let's grab this, put this in here. Expected alpha from the input. What is this? Alpha ident. I guess this is too simple of an example, but basically what you end up with is like anytime you have a return type, it could be many return types because it's not well typed. So you don't get like one child, you get like an array of possible children that has one child in it. Trying to focus without wondering what was that Peanut song, ADHD much. I think it's the intro song. I think there's only one intro Peanut song. The one with the piano. I don't know the name of it, and I'm not going to play it on stream, so unfortunate. You know if any recent testing comparing Bevy's performance with other engines? What aspects of performance? The thing that I have to say about performance in general is it's significantly easier if you're comparing to sorting algorithms, right? Because you know the big O, you know how they operate, you can like isolate them from everything else, and you can kind of run them, you know, thousands of times to get the standard distribution of like their performance, right? And even then, you can end up in situations where like other stuff running on your computer messes with the, you know, output and et cetera, et cetera. So like running benchmarks is hard even for simple things. Constructing valid benchmarks for entire games sounds exceedingly difficult to me because the way that Bevy is constructed, like the ECS and the renderer and etc., is not the same way that Godot is constructed, is not the same way that Unity is constructed, of which they have multiple renderers, right? Is not the same way that Unreal is constructed. So it's really tough for me to say that any one of them is more performant than another one. If you start talking about like specific features, like you can start talking about how Nanite deals with large static geometry really well. Meshlets are the term for that effort inside of Bevy, but I'm hesitant to say like, oh, you know, Godot is faster than Unity. Like that's a nonsensical kind of statement. We need to pull up this crate that I wanted to play with here. That's right, yeah. There we go. Async. This is the crate. Question is, did I install it already? No, I didn't. So I'll add that in Bevy. I believe this is 0.17 compatible. I actually didn't check before stream. Basically, there's an async working group happening right now for exploring how to integrate async with Bevy, which is very cool. And this is one of the crates that is kind of exploring that design space. And the author asked me to play with it, so I figured I would do that on stream. And we could potentially come up with use cases and see what they look like. So this is going to be kind of exploratory. I am not super familiar with this crate. I have looked at it before, but I haven't used it all that much. So let me run a cargo build just to get that going. So runtime agnostic ECS access for Bevy. This crate lets you run async work on any executor, Tokyo, Bevy's task pools, or another runtime. So notable here is that Bevy does have a task pool implementation. Tokyo is usually something completely separate. There are other runtimes like small, SMOL, etc. And then safely hop into Bevy's world to read or mutate ECS state using the normal system param. So this is really cool because this is really an ergonomic way to deal with the async world. So experimental stopgap crate, like this is not a, this is an experimental stopgap crate. Is a simplified version of functionality, potentially going to upstream into Bevy, where it could run in parallel with other systems. Today, world access is serialized into short access windows inside of the schedule. And there's a list of limitations at the end. So we could use any runtime we want. We'll probably try Tokyo at some point. Maybe immediately. Maybe we could just use futures. That would be interesting. Seems like we get access to res mute query, any other system parameters. Add one plugin and await a single helper future. So let's, I guess they start off with a Tokyo example. So let's start off with a Tokyo example just to get this kind of going. Can I copy and paste this without losing my copy paste? Okay. So we have the plugin, Bevy's Prelude, a random resource called My Resource that gets initialized. Minimal plugins is interesting, not default plugins. So this is just going to run in the terminal. The async plugin comes from the async crate that we're working with. And then we've got startup and update, spawn a Tokyo task in startup, and then show the value in update. Pretty standard Bevy setup in general. I probably want to switch this to like default plugins or something, but we'll see in a sec. I don't think minimal includes like a window or anything. So hello from Tokyo, the effective hello world. We could also do, well, I don't know if we could do info once because this would be on change. See if I can kill it fast enough. I probably can't kill this fast enough because it's just repeatedly printing as fast as it possibly can. So I guess they've removed a bunch of stuff here. So we could do default plugins. We'll get a window if we do that. This should still run. Hello from Tokyo. You know, runs a little bit slower as the window is starting up and then speeds up. One of the reasons for that is that if you're actually running the winit loop with a visible set of stuff, that it has more work to do and more restrictions. Whereas if you're not, you can kind of just like speed through it. So what do we get here? We get spawn Tokyo task in startup. This takes world ID resource. World ID resource is from the async crate that we're looking at. I think you have to, as part of the way this crate works currently, identify the world in which you are operating on. So a resource containing the current world ID, you can also obtain it with world.id inside of a regular system. Cool. So this is just like the current world, wherever your system is running. So it's a nice little helper function, which is cool. And then we spawn a thread, which is interesting. I wonder what the WASM pattern would look like. Is WASM mentioned in here at all? No, it's not. So we're desktop only for now. This is running the Tokyo runtime. I assume that this is like, you would do this whenever you wanted to. Let's see, we've got the Tokyo runtime. We've got a block on for the runtime that executes this feature and awaits it. And this is async access for that resource. And then runs, what is my? My is the resource. So we put our queries here-ish. We can look at the function signature for this in a second. Maybe we should bring up the actual docs. We can do that then. Oop. I always reverse the names of everything. I do this for mesh material too. So async access takes the world ID and an ECS access function. That function is an FN once, where P is a system param, and we get the items, and then, so it's a system, basically. And it is the system param, the function itself, and the output of that system. Morning, Ryan, how are you? Looking at some async Bevy stuff. So registers access windows in pre-startup, startup, post-startup, pre-update, update, and post-update. This feels a little bit like the apply deferred pattern. Apply deferred has come a long way in a number of Bevy versions. But if you queue a command, there needs to be an apply deferred to kind of apply that command. So this pattern of having like a moment at which this happens in each system makes sense. Now, things like observers don't deal with the apply deferred stuff because they just apply things immediately. So open question as to like communication with this runtime. Let's see, update stuff. This just runs async access inside of a random system, which is interesting. Doing well, thanks. Good to see the daily streams. Yeah, I'm enjoying it for the moment. You know, I don't know how long I'll keep it up, but you know, if everybody bought enough Rust Adventure for me to do this every day, I would do it every day. Rio says, which tiling tools do you use in Mac OS? I use Ubai. That's the only one that I use. It's pretty solid. It works for me. It's worked for quite a long time. One of the things that I really like that it does is it removes the window shadow from all the Mac OS windows. And it removes a lot of the, like, this window is selected kind of things. So the window shadow, depending on where my cursor is, doesn't like overlay on other windows, which makes it really nice for video recording. I don't think that everybody has that use case, but you know. Anyway, Yabai is solid and I like it quite a bit. There are alternatives too. If you don't end up liking Yabai, there's, I think it's called Aerospace. I can't really remember the name of it. Okay. So quick start with Tokyo. How do we interact with Tokyo in general? Do we just automatically get to do that? Because this just has kind of like a function that does async access. So does this have any indication of... No, because async access is a future. This is an async function. So the question is, does this implement async systems? Or is this just kind of something that we need to like keep spawning? You never really thought of doing cooperative multitasking in video games. Just multi-threading always worked for me in game engines. Yeah, I think there's a lot of people that want to do async stuff. One of the examples that I want to try to get some implementation for here is actually asset loading. So asset loading is async inherently, right? You load something in, it gives you a handle to where that thing will be. And then over a series of frames or however long it takes, it loads in that file data, parses it into a bunch of assets, and then like it actually works, right? So one of the things that I would like to do is try to load a GLTF file in a way that is a little bit more maybe ergonomic than the current way. The current way, so let's create a file here. Let's see, bin main.rs, right? Do I want to pull Skeen in? I don't think I need to pull Skeen in. I do need a GLTF file though. So do we have Blender? Here's a Blender. Here's a Blender for our 2D visibility stuff, which is cool. I don't think I saved this file. I probably should save this file. And it's not really that important. I'll create a new file. This is probably not going to be the thing that I use anyway for that. Don't save. So let's take, I guess, this cube and just export it. And what directory are we in? This is not even the right. This isn't even the right place to be. It just pulled me over to the other desktop, I'm realizing. Where are we? We're in temp, right? Or did I put this in Rust Adventure async? So let's export. I make everything a little bit big so people can see it. So sometimes my layouts look a little bit cramped and wonky. Let's do GLTF. Let's go to GitHub, LMN, Rust Adventure Async somewhere in here. New folder, assets. And this one is just going to be like cube.gltf. Nothing crazy, nothing super interesting, just cube.gltf. Now we can get rid of Blender for now. And in our assets, we have cube.gltf. I used UI for window management. Do you have a video or anything using Bevy's stepping plugin? You discovered that last night and wanted to play with it today. I don't have one using Bevy's stepping plugin. I think stepping is really interesting, but it takes a little bit of effort to set up. So for context, for people who aren't aware, there's Bevy examples. Is this ECS stepping? System stepping, yes. So there's a demo in the Bevy repo called system stepping. And system stepping basically lets you step through a frame, step through the systems individually, which is really, really cool. And I could probably make more use of in demos and such. But I just don't use it all that much. It requires a decent amount of setup. I feel like it requires some infrastructure inside of each system. And this demo even just like manually ticks the update for the app. So I don't know. Stepping is very cool, but it feels a little bit like off the beaten path to use. Yeah, they use it in the breakout example too. Yes, they do use it in the breakout example. Where's the games area? Breakout. Mod stepping. Right, so stepping plugin in the update schedule, the fixed update schedule. I don't know. I don't have a video on it. I don't feel like many people are aware of or use it. It is very cool. I don't know. There's something about it that just feels a little bit off the beaten path. Yeah. I don't have a video on it, if that's just the only question you have. But curious to see if you do actually make use of it. It seems really helpful for seeing how things are working per frame. I think it would be very helpful if things were, if you could see how things were working per frame. But if you have to scatter stepping stuff all over your application, fewer people are going to do it. I don't know. It is very cool, though. I've definitely used it. I feel like one of the things that comes up for me with respect to stepping is that it's usually better for me to create a second demo rather than implement stepping over the top of something. Because if I implement stepping over the top of another demo, then I have a bunch of stepping code interlaced with a bunch of regular code. And then it's hard to figure out what exactly the demo is supposed to be. I don't know. Maybe I should use it more. FN main, app new, add plugins, vault plugins, add system startup dot run. So this will run, and this will be fn startup with, I guess, asset server. Right. And we need struct like my GLTF or whatever. So we have resource. This is a handle to a GLTF. And then this asset server loads like cube.gltf. And we want this to be inside of my GLTF. And we want to commands.insert resource this. And we can do mute commands here. And then there's a couple things that happen. One is that you can't observe this, right? You can't do like .observe on this load. So if you want to like check for loading, let's do update. Right, we've got check GLTF load, and this is like fn check GLTF load. This will be a reader, which I think has to be mute, which is a message reader for asset event for GLTF assets. And for event in reader.read, match event. Not, oh, did I call this bins? This is supposed to be bin. I was wondering why I wasn't getting Bevy GLTF, we'll call this. So match event, fill match arms. You get all these asset events here, right? Added, modified, removed, unused, whatever. Loaded with dependencies is the only one we actually care about. So we're just going to let everything else slip through. And then here we need to, for example, look for this resource. And then if ID equals my GLTF dot 0, like info loaded, else do nothing, I guess. We don't really want to not load. We don't want to dump out a message to not load it. These are not the same thing. There's a little bit of shared reference stuff going on here. So cargo run bin Bevy GLTF. If you've never seen multiple bins before, you can have a main.rs, which is just like the default entry point. And then anything in bin takes its binary name from the file name. So typo up here, add systems. And then no implementation for asset ID GLTF equals handle GLTF. Can these coerce into each other? We have the asset ID on the left, which is the ID. So this handle .id, I think. And then the left is a reference, so we'll use a reference. So we're getting the asset ID from that resource. So this resource is a handle to a GLTF, right? Resource.0.asset ID equals the asset ID that loaded. When it's loaded, it loads. So we run this, and then we end up with the GLTF has loaded, right? So theoretically here, we could, commands.spawn the scene, right? Scene root. We need to grab the GLTFs, right? Res assets, GLTF. yada, yada, yada. We need commands here because we're going to spawn something in. So this is going to be let okay. I think it's okay. Maybe it's sum. Let sum gltf equal gltfs dot get ID. Else continue. Right, so we've got all this stuff, and then we hit the ampersand here. Sorry, the dereference, not the shared reference. Scene root, so we've got our gltf, and this has like a default scene in it probably, so I'll just unwrap that, and assuming that I didn't just mess up horribly. Oh, right, I need to... Default scene is a handle to a scene inside of an option, so we can like as ref. .clone. So we run this, we should see a cube on the screen. I don't have a camera, sorry. I'm so busy focused on the gltf. Transform from XYZ. We'll call this like 5, like 2, 5 maybe? Looking at vec3 0, vec3 y as our up axis. This needs to be inside of a bundle. This is literally how I write code when I'm off stream. I just write long lines of stuff and then let it format. So you're seeing real what I do off stream. So we've got a camera, we've got a gltf loading, we've got a scene that we haven't happened to access, and now we've got a cube. So this is kind of contrived, I will say. You can just do like cube.gltf scene 0 and avoid this whole thing. The problem with that is usually inside of a gltf file, you have a bunch of different stuff. You have animations, you have scenes, you have et cetera, et cetera, et cetera, right? So if you have a scene that has a bunch of gltf stuff in it, right, and you want to spawn that scene, typically a bunch of those things in that scene will have animations. Those will also be in the gltf file. And you want to use those individually. So like you want to be able to reach into this gltf that we just got, right? And there's like named animations. And then you can use named animations to build up an animation graph, to put it on the right thing in the scene after you spawn it, et cetera, right? So it would be nice if we could change this using async, right? This is a contrived way to load and spawn a scene, but imagine that we're not just loading a scene, but we're also, you know, building an animation graph and setting up animation blend trees and like, you know, pulling things in from different places or like spawning multiple scenes. Like we're doing more work than just one scene, right? Otherwise, this is too much scaffolding. But this is like what you end up with, right? This is the state of the art, I guess, for a gltf comes in, you do some processing on it. You can, you know, separate this out even more. So when this ID comes in, we could have in here an observer. So like commands.trigger gltf load with that ID, right? And then this could trigger an observer. That observer could hold all of the stuff that is relevant for handling gltf files or whatever, etc. You can also use Bevy asset loader. Bevy asset loader takes a different approach. I never have a Chrome window. It's always like 5 terminals, 3 VS Code windows, and like the energy drink that I didn't finish yet, just sitting on my desktop. Bevy asset loader. So Bevy asset loader is super cool. I guess we should pull this in, but Bevy Asset Loader allows you to define a resource. Where is an example? Here's a resource. So define a resource like this, which is just a collection of assets. This can be a GLTF file instead of an image. And you just say, hey, this GLTF file is part of this asset pack. Then it lets you say there's a loading state and a next state, and Bevy Asset Loader handles all of the loading, and then will transition you from asset loading into next whenever that loads in. This, I think, is, can I show all of it? Close. This, I think, is what I would do in a production application right now. I would have Bevy Asset Loader. There's a bunch of different ways you can use Bevy Asset Loader. I would probably have some kind of substate for level loading, and do something a little bit more production ready, right? Totally get that. You're doing some simple 2D collision detection and want to use it for some visual debugging of order operations. You'll report how it goes. Yeah, please do. Maybe I should have, yeah, I don't know. I feel like the demos, there's a strain in the demos between like a thing that does a bunch of useful things and shows a bunch of useful stuff and like just the thing itself. And I think the thing itself is the most useful piece. And anything else additional needs to be in a separate file or a separate visualization or whatnot. So I don't know. Maybe I can figure out a way to like build everything up in layers. I don't know. So TLDR, Bevy Asset Loader will let you go from state to state. It would be cool. Where's our thing here? It would be cool if I could be like asset server load, like .await, and then do some work with the GLTF file. That would be sick. So that brings us to this original demo. Does this runtime? I don't want to boot a runtime every time, right? There's no demo in here of like using channels. This has iotaskpool.get. I don't think we have any helpers like that for the runtime. Moving the runtime runs in a separate thread entirely. So channels are usually the way that you would communicate back and forth, right? You would have the Tokyo runtime accepting messages and then returning messages. Are there any more demos in the repo is the other question that I have about this. Where is the actual repo? Right, because it totally makes sense if you're going to have something that is you're effectively building a web server at some point using channels, right? So you're sending messages, it's doing some work and sending messages back. But the thing that I'm really interested in is the ergonomics on the Bevy side. Is the GitHub repo private? I don't think it is. This got sent to me in a DM the other day, so I'm just going to check my... I don't have a link to the repo. Let's see. Can we find it? Bevy, Malik, async, GitHub? Might be private at the moment. I don't know. Source, examples, Tokyo example. Here we go. Async fetch example com. Maybe you could just create the runtime and start in a component and then spawn tasks on it. Not sure if you need mute runtime to spawn tasks. Yeah, I'm kind of looking at I'm looking to the crate specifically for some direction there. Because like I could try to do a bunch of stuff, but I think that this is designed to work in a specific way. There is some unsafe here under the hood. From what I understand, the unsafe has been validated by multiple people who really know what they're doing. So it shouldn't be an issue. But I just want to make sure that like I'm doing things in the way that it might expect. All right, so here's request. And here's async access with world and something else, and you can await. And fetch example com is called where? Run the async task on its own OS thread with a dedicated Tokyo runtime, so it doesn't require any global runtime integration with Bevy. It feels weird to be booting up Tokyo to run one thing. Bevy is expected to handle this for you in the future, right? This is one of the prototype crates that is coming out of the async working group. So yes, there are people actively working on this. The reason I'm looking at this today is because it's early prototype work for things that might get upstreamed. This is not like the end API. It's not like the goal API of async stuff in Bevy. It's just a crate that does some integration. And there's a whole bunch of like qualifications and limitations that are explicitly exposed in the documentation. And if this gets upstreamed, it could run in parallel with other systems and whatnot. Yada, yada. So fetch example com runs inside of a block on inside of the runtime. But I feel like having... Let's look at new current thread. Let's take a look at new current thread, because this may be the intended use of like a single threaded Tokyo, so to speak. I'm so used to Tokyo being, you know, multi-threaded and whatnot, but I think this is actually just booting up a single threaded Tokyo, which would make sense, because then we are supposed to run the runtime. It feels weird. It still feels weird to boot up the entire runtime on every thread. I assume that that is like a temporary limitation. Will this always stay a manual process, or is Bevy going to run systems in parallel? I don't think we know the answers yet. What we're looking at here is like early exploratory prototype work. There are limitations that is placed on that work being outside of Bevy itself, right? So a theoretical integration of this with Bevy might be able to provide like quote unquote async systems. But I don't think we have any actual answers as to what this is going to look like when it lands. It's not even clear that this is going to get upstream specifically, right? if it does get upstreamed, I do expect higher level sugar, right? That's always what happens. The way that these features kind of develop is prove that it works, prove that everything is sound, then see how people are going to use it and build the user APIs for how to use this thing at a higher level, right? For example, there was a pattern where people wanted to, like, we implemented states inside of Bevy, right? And then what people started doing is trying to spawn things when a state started or remove things when a state ended. And what ended up happening is that got encoded as this component that just Bevy just handles for you now. You don't need to manually do either one of those things. Well, the spawning, yes, but you don't need to manually despawn things when a state exits anymore. You just stick this component on it, right? So these APIs do develop into higher level APIs over time. And this is still pretty early. Weird that it doesn't have an example MPSC channel starting from the Tokyo runtime that you can talk to from Tokyo's thread and Bevy system. I think that if you're going to have a long-term running Tokyo, you can. And then you would use MPSC, but you can also kind of do that today. Right? Like if you start a thread and you boot Tokyo into it, I'm pretty sure that you can set up channels to work that way. And thus, in some system at specific points, you can pull that channel, right? This example uses something a little bit lighter weight. It's an IO task pool. I think this async access is really kind of the core innovation inside of this crate. And that is access to the world inside of async functions. Current thread just runs tasks after each other, not really in parallel. Don't see a reason to use it this way. Doesn't seem like a great example. It's not a web server, right? So it is running a single task. But keep in mind that the point of this crate right now is not I'm running a Axum web server and a threat, right? The point of this crate right now is you can access the world, the Bevy world, from an async function. That direction is the core innovation here. So I don't think it would really matter all that much going the other direction. Let's see, async access, world, push, task pool. I feel like this might not actually help us right now with asset loading. Let's see what other, so there's async plugin, there's async access. Runs during next access window. And a resource containing the world ID. So yeah, I mean, this crate is really effectively this async access, right? I think this example is really tripping me up too, because not having a where do you use this? Right, because this one spawns the task in a separate thread or a task in the pool or whatever. And I feel like we still need to... I feel like we don't get the user experience that I was thinking of for the asset stuff from this API. This API is definitely interesting from the perspective of, like, I'm going to make network requests or something like that. Asset loading and longer than one update request will only benefit from a long-lived runtime. That's also what most devs will need a runtime for anyway. I don't know what you mean by... Like, do you think that this only runs inside of the current system and blocks it? Because I'm pretty sure that's not what's happening. Right? Like, I'm pretty sure that you're spawning this thread, you're spawning this thing, it's running somewhere else. Bevy's still running its frame updates, right? Like, it's not blocking the Bevy update cycle. So, a thing like asset loading, for example, I guess we could do manually, right? Let's see. Docs.rs Bevy is loaded, right? Handle, handle. UID untyped. See, asset ID, index, default. Where are the loading APIs? What are the loading APIs? Loaded. Load state is loaded. True if this instance is loaded. Asset server, load state. Okay, so we need access to the asset server. We can check the load state of any handle. Right? Environment map, diffuse map. Diffuse map is going to be a handle. Yeah, diffuse map is a handle. So this is just using asset server load state is loaded. So theoretically, this future could do something where it just kind of like constantly checks for that asset to see if it's loaded and then does something. Which is kind of an improvement over the asset event, because the asset event kind of requires you to handle everything in one spot, whereas this would let you fire off multiple tasks that then watch for different things. You really wanted smooth async systems for server-side Bevy to talk to a database or whatever. Yeah, I think theoretically to get like an async system that you could await in, there would have to be an upstream implementation. I don't know that that's something that can be done in user land. This is a user land crate. So what we're doing here is spawning a Tokyo task for the current world, right? Spawning the thread, using Tokyo on this one runtime, doing basically one future, doing our async access. And I think we could just loop over this with the await, and that would end up checking at every access point to see if the thing is loaded. Bevy Malek Async seems to only handle Bevy access and async, not runtime execution. Not sure how long systems can run. This isn't... Right, spawn just spawns something and it goes, right? Like this isn't spawn scoped, right? We could totally test this too. Right, spawns a new thread, returning a join handle for it. The join handle provides a join method that can join the spawn thread, yada yada. Yeah, the spawn thread will definitely run longer than the system. Yes. That's kind of what I was trying to get at. If we're on the same page, then I don't need to go through it. Right, so we're not blocking the system. We're spawning a thread, it's running the thing, and then it's finishing its work. And the thread can run as long as it needs to, and the systems and the rest of Bevy just keep running. Hi, Chris, late into the stream. Hope you're having a great Saturday. Hope you're having a great Saturday as well. Listening along while skiing. So I think we can form this into a demo. Let's try to get it to work. New file. I feel like I should rename these. Right? This should be renamed GLTF Bevy, so that these kind of like line up with each other as we use them. So, current situation in default Bevy implementation is we have a startup function. We have to create this resource. We have to load the asset. I feel like we'll have to have this resource regardless. Not having this resource feels really weird. So I think this scaffolding all still sits. And then the part that we're really replacing is this check load. So theoretically, this would be a message reader inside of an async system that's just kind of like checking at every kind of like async sync point is what I'll call them. The working group will have to come up with something nicer because you can see people crossing lots of threads and frequently running systems. Yeah, to be like perfectly clear, this is not like an end user API output of like if this got upstream, the working group wouldn't end, right? This is a prototype of how to do access from the Bevy world or to the Bevy world from an async system. That's it, right? So like, don't imagine this as the thing that is going to ship. Imagine this as a prototype for accessing the Bevy world from an async system, right? Because like the things that you're bringing up are all issues that are like not related to that, right? And those things are not tackled in this prototype. That's why I spent some time at the beginning looking at the crate itself and trying to figure out what it was trying to achieve. Because it's not trying to achieve like an async system, right? It's not trying to achieve the ability to do like await here. Okay, so let's grab some of this. I still think you're focusing on the wrong thing. You're focusing on like all of the things that this crate is not trying to handle, right? This crate is trying to handle Bevy world access from an async system. All of the stuff you're bringing up are like unrelated topics that could have different prototypes. Use Bevy prelude, async. We need the async plugin. We do use this, so let's run this. You think what is kind of missing is to allow an external async runtime to mark a Bevy system as ready. But yeah, not what the crate is trying to do. Also, hi. Hey, Rem, how's it going? Yeah, I think that like having a quote async system of some kind would be really interesting. Why is this not working? No bin called. Oh, because I'm distracted. That's why. So this will have this resource. This resource is basically the same thing that we're trying to do. All this does is stick some data in that resource. So I'm curious as to what else we can access here. That makes sense. Access. Oh, well. Got halfway through that message before it got deleted. Okay, so let's make this our GLTF handle, right, instead. And let's make... They do an insert resource or a init resource here. I think we want to... How do we do this? This is... theoretically like this. I don't know exactly when these relate to each other, right? So this is going to be command queue, and this is going to be a spawned thread. So I think this res mute might have to turn into an option if we do it like this. I feel like it's always funny when people don't make use of the debug sigil and such. That makes sense. Who needs a runtime if you can't access Bevy? Well, like you said, you could pass things over the channels, but without access to like being able to check resources and stuff, the interaction becomes a little bit tougher, right? You have to package up everything that you're going to package up, send it to, you know, your async processing. You can't interact with that at all while it's doing that, and then it gets sent back, which you can totally do today with like task pools, right? So commands, mute commands. I think this is going to crash. It doesn't. Interesting. So either this runs after the command queue. That's really interesting. You mean the alternative would be invert control, where the async runtime just provides the data somewhere and then notifies Bevy that it's done? Yeah, I mean, you can do that today, right? If you spawn something in a thread or whatnot, or you use the IO task pool, like one of the demos, for example, I'll bring this up actually, since we're talking about async and command queues and stuff. One of the demos in the Bevy repo. Examples. Async tasks. External source or async compute. I forget which one it is. Did I write command queue wrong? Anyway, you can spawn a bunch of tasks, right? For like the async compute task pool. You can do a bunch of stuff. You can build up your own command queue and then throw that command queue back at Bevy and have it execute. This is a thing you can absolutely do today. But you have to build up those commands inside of the async and then send the commands back to be executed. So theoretically, what we are allowed to do currently is access commands in here. But I don't know that that's true, but we're going to try. So the question is, we need that demo of multiple. I think it's going to be the same kind of function signature that we use regularly, but let's go. Yeah, it's just a tuple. So we'll get our tuple in here, right? Typical query. We've got our resource. We need the asset server, which doesn't get written quite like a query. It gets written like a system param access, which people might not be used to, but if you have world and you do like world dot, what is the API called? It's not query that I'm thinking of. It's like world dot system param, world dot system query or something like that. Anyway, you end up getting like this kind of types over here and variables over here kind of separation. So this is not the place to put this. This is the world ID. Hang on. Yada, yada. This is GLTF, and this is asset server, right? So here, then we do our async access. So this is going to be asset server dot load state. GLTF dot 0 dot is loaded. Right? If it's loaded, then what do we do is the question. The other question I have is, actually, before we do this, I have a question about the original example. This hello from Tokyo, how often does this run? Is this just, because this just should just run once, right? Block on, async move, async access, await, be done, right? So block on, async move, async access, this should just run once. So interesting, the func parameter is called on your thread. Bevy does not manage it. Are you looking at the source code? Yes, this doesn't get passed back, I don't think. I haven't looked at the implementation too deeply. So I don't know if info works in here. Let's just check. Right? And let's get rid of this info so that we don't get overwhelmed with logs. And it only runs once, so we never see it. So do we do something really silly? And loop our, I'm kind of relying on the async access to be like, okay, we're going to check every async access, but this isn't going to be like stall on the async access. And I don't know if that's true or not. Okay, it does get loaded at some point. Let's get this back into play and see if this is, because this is running an update, right? So we can see these kind of interleaving, right? We get about 5 checks, which kind of makes sense because I think there's about 5 systems that have this. We'll call it async deferred system. So we get an update, right? At some point. I think pre-update has the async deferred. Let's look. It's actually listed here instead of guessing. Pre-startup, startup, post-startup, pre-update, update, post-update. So pre-update, update, and post-update are running. And then eventually this loads. So we hit those a couple of times. If you access the asset server, does Bevy properly load the asset, or does it slow down the game like some games that drop frames during loading screens? Are you asking if you access the asset server regularly, or are you asking specifically in the context of this async library? If you access the asset server, it shouldn't slow down the game that I'm aware of. I don't think. I have noticed some, like, if you're trying to spawn a bunch of stuff and the shaders need to compile and stuff, that can cause some like issues. So there is some kind of like shader pre-compilation that you want to do and stuff like that. But the actual act of loading the file, no, I don't think so. Right? I think there are things that kind of impact the user's experience, is the way that I'll frame it. For example, if you have a bunch of really big shaders or something, those do need to get compiled when they're first spawned for materials. I know that Chain Boom experienced this. They actually put a loading screen in their last Chain Boom. They should, I think this has a loading screen. Not this loading screen. This loading screen is a different loading screen. Loading assets. So this is information that you can access through like IES Progress or Bevy Asset Loader in IES Progress, and then compiling shaders. I don't know what they were doing with their shaders where they have like 46 shaders that need to compile. The source code for this is open source. You could take a look if you wanted to. But they are definitely doing something here where they're like pre-spawning stuff, making sure the shaders are compiled, and then putting you into the game. So there's definitely impact depending on which piece you're talking about, right? But I don't think actually loading the file is slowing the game down. So GOCF asset server, this is loaded. This is kind of a lot of scaffolding to get this to work, but I assume that this would like get packaged up. Right, and then we break out of the loop. Do we need to label this loop to break out of it? Forget how to label a loop. Hang on. I label loops basically never. There we go. Check asset and then break check asset, right? I guess we don't really have asset access here. Because this is a closure that gets called by something else. I don't think we're actually quote unquote in this loop when this is run. Cannot break inside of a closure. Yep, that's exactly what I was expecting. So the question is, this can output something, right? Async access? I think so. Right, let finished equal async access. I think this is the output parameter. This would be, let's just call it an I32 for now. And let's say this is going to be an I32. And if this, then return 1, else return 0. And then if finished greater than 0, break the loop. So just a little bit of coordination here where we have the system output that we're actually storing in a variable that we then check after the system is done. Right, and then this should hit loaded exactly once. It hits loaded exactly once and then stops. Does it impact frame times? A more interesting loading screen like in Bethesda games, for example, would that stutter? The asset server shouldn't cause stutter inherently. Like I said before, the shader compilation, I think would be the thing that causes that if you see it, right? Because if you're doing something interesting, say on the GPU, and you start sending more work to the GPU to compile all these shaders or whatever, those two things can kind of interfere. And like, there's not infinite resources on a user's computer either, right? If you used a ton of CPU and you had to do more CPU processing for, I don't know, maybe really intense CPU generation for procedural generation for a world, obviously that would work. But like inherently, no, I don't think so. Maybe use control flow break. Oh, that's a good idea. Wait, why is this import control flow? Did I pull in the wrong control flow? Oh, please. Oh, right. They take, it's like a result, right? We don't really have variables for either of these, so I think unit would be fine for us. Right? We don't really have any reason to do either of them. And then this is control flow break. And this is control flow continue. If control flow, do we have like little is continue, is break, is continue, is break? There we go. If control flow is break, break. Ta-da! I do like the control flow. That's a great suggestion. That's another benefit of Bevy over other engines. Unity, for example, can't properly load assets while keeping a stable frame rate, at least back when you were using it. Yeah, I mean, like, with the obvious caveats that if you shove too much work, like computers have limited resources. So I can't say like 100% that your, you know, intensive CPU procedural terrain generation isn't going to impact something. Or if you have like some massive amount of shaders to compile or something like that. But inherently, when you just load a random asset, no. This doesn't need to be mutable. This is loaded. Res. So theoretically, this can be like commands too, right? So where's our spawn code from the other scene root? ID equals ID, these things, and then we also need GLTFs. So pull this in, pull this up. This then doesn't get to continue. I guess this has to return control flow continue because of the way that we've defined our function, which is totally cool. I actually really like that. And this is gltf.0 with our deref coercion that we talked about in our language stuff this week. Let's see. All of this stuff, it's a lot of scaffolding, I will say. I'm not concerned about the scaffolding though. Right? Like there's something worth acknowledging here in that this working is the point, right? Being able to access these system parameters from this system function or from this async function is the point, right? This scaffolding around it isn't necessarily going to be there forever. Like if everybody was doing this every time, this would get wrapped up into like a quick thing, right? This would be like Bevy spawn async task, right? And then you would get the interior of the block on. Did I do this correctly is the question. We don't have a camera because I forget my cameras. Why would I ever spawn a camera? Nobody likes cameras, right? The number of times I've forgotten to spawn a camera in a demo. It's at least 2 nickels, but it's weird that it happened twice. Theoretically, you could also use question mark to break out, but that wouldn't really be clear. Yeah, I kind of like the explicit control flow in this scenario because we're not really doing something that is like pretty typical. Can commands be sent from async to Bevy without this async access function? I think the async access function is the thing that gives you access to Bevy. You don't get access without the async access. But the answer actually is yes, because we talked about this in the demo earlier, right? If you look at the examples, ECS, async tasks. In the async compute, I think command queue, here's a command queue, right? Stored in a component. Here's the command queue being built inside of the async function that gets pushed into, and then you get to like return the command queue here. So this is the task spawn right here, thread pool spawn. At the end of the thread pool spawn, you return the command queue. This inserts the compute task, and then there's another system that checks for these components and grabs the command queues out of them, if I remember correctly. Right, this blocks on the future, pull once, grab the command queue off the future, execute it, or like append that. So you can already kind of do this already without the async access function. Does this only work with the task pool? I don't have an answer to that. I don't have an answer to that because I've never tried to use Tokyo. I've always used the async task pool. I think theoretically, if you do the thing that you would expect to do, where you spawn Tokyo somewhere else and then you deal with the back and forth, the things that I can say are that building up command queues, right? Building up command queues does not require any special access. So you can build up a command queue anywhere and then send it over to Bevy and execute it. Right, because the only things that you're actually working with in here are types that are shared between, Bevy and the code that you're writing. If you're going to access the world, it's going to come in through the argument in the closure, because this is a command. It gets world access. You use world to get everything. Because you use world to get everything, then all of this happens when the command is applied, which means you can construct this command queue anywhere you want to, because all of the interaction is with that world argument. So if you wanted to, even outside of the Bevy application, you could build a command queue and then pass it in when you instantiate a plugin and then execute it like when the systems start running. So there's really no restriction from that perspective. If your approach is I can send all the data I want to away, and then it can return me a command queue that I then execute, you can do that today in almost any way that you want to. The thing that you can't do today is what this async access function does. Or like, technically speaking, you can do it today because this is a third-party crate that just exists, right? But what I mean is in upstream Bevy, there's no function that gives you access like this gives you access. So what we're doing here is we've got our startup system, right? Spawn Tokyo task. We decide that we're going to spawn a camera. We decide that we are going to asset server load this GLTF in this resource. We do still need this resource, right? I don't think that it's an interesting question to think whether or not this handle could be like cloned and passed to the async thread. But the resource approach works. We start the runtime, single-threaded Tokyo runtime in this case. We block on this future. We choose to do a loop. We could also like decide when this runs to some extent. I think if we wanted to do like an access once per second, we could do that here, right? Every second we do an async access and then it gives us the stuff. But we use this async access function with some system params. In this case, we're using system outputs, which is really cool because I feel like I don't use those quite all that often. We get the world ID and our arguments. We use all of the regular stuff, the asset server to check the load state. We use the GLTF resource database to grab the GLTF. We use commands to queue the scene root spawn. And then when we're done, we break or we continue. So very cool that this works. is kind of what I'm getting at. Let's see, the loop here would be nice to break out and write somewhere else, right? So like this async move, I don't think we access anything from the ecosystem. So this doesn't capture. So it's because this doesn't capture, we can take this whole thing and do spawn GLTF when ready. So fn spawn GLTF when ready. This will be async. Do any async work here, IO compute, etc. I guess we can leave that comment. We do capture world ID, actually, now that I'm looking at it. So this needs to be world ID. Is that right? This is world ID resource. Where's world ID? That's what it showed over here, right? World ID, world ID. World ID needs to come into scope. That's a Bevy type. That's not even this async library. So then we have this loop that we're running. We have this control flow. We have this async access. This kind of gets a little nested. I don't think we capture anything here either, right? So here's a closure. That ends here. So let's grab this and call this, I don't know, spawn GLTF. A little awkward because then we also need to specify all of these, I think. Kind of duplicating the function signature here. As a working group commented on what the goal is, threads can be spawned and async can be executed on task pool. Tokyo would only be needed to use crates that require it. This is supposed to be async runtime agnostic. The fact that we're using Tokyo here is kind of just like because we can. You could also use an IO task pool. You could use small. You could use futures. You could use a number of different things. We're kind of just using Tokyo because we can. That's it. But this whole library is runtime agnostic. Hey, Jordan. Good to see you. Thanks for saying hi. Got a couple of errors here. I didn't pass in the world ID here. We need to do that. This async access is interesting. Inline. Oh boy, is that a fancy type signature. Is that really what I'm going to have to do? Because it has to implement fn once. Expected a function that takes a single 4-element tuple as an argument, so it's actually this. That's why. Okay, that makes sense to me. Kind of unfortunate to split this function out like this. because we're kind of destructuring a thing we just defined. But it does work. And maybe we could clean this up a little bit. Maybe this could be inferred. I don't actually know. No, that doesn't infer, at least for the initial. I wonder if this can't be inferred because we have to define it if we're defining a function. So the only way that gets inferred is if we are using a closure, which makes sense. Question still stands no matter what async runtime. So what's the question? Has the group commented on what the goal is? Threads can be sawn. Yes, I believe so. Let me check before I say a definitive answer. Come on, send me to the top. Let's see. So the premise here is that async tasks occur pretty regularly. They're used for work that is too big to complete in a single frame. Examples given are terrain generation, asset loading, game AI, all sorts of commonly handled async. The ergonomics for Bevy's current approach are not as good as they would want them to be, and the goal is to improve them. The scope of the working group is limited to the raw ECS APIs that allow for communication between ECS and async work. Any asset-specific UI or other integration work is out of scope, so this is only the ECS APIs. And full-blown async systems and observers are also out of scope. So we're not going to get async system out of this. We're only going to get the low-level ECS APIs. I think that's a good scope because there's a lot of complexity there, and getting some ergonomic improvements to be able to do this, like this async access function, make a lot of sense. And then other things can build on top of that once it's merged. Async commands are a natural fit, and there's hopes for async APIs to access entity and component data, but there's no design doc. Networking probably is hard without Tokyo or any async runtime. This is probably supposed to help crate developers. Yeah, well, the working group is definitively low-level ECS APIs, right? It's things like this access function, right? This async access here, this is an example of something that the working group has within scope. But full async function like async spawn Tokyo task up here, not in scope. So this will be really interesting. It'll be some improvements, but it won't be the full, like it's not going to be, how do I frame this? It's not going to be like a BSN, we wait for a year and then like async systems get dropped on us kind of thing. It's going to be a incremental step up to things. They also list a bunch of crates. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 crates in the ecosystem right now for doing various async stuff. So Bevy mod scripting, Bevy coroutine system, Bevy mod async, Bevy defer, Halka, Bevy flirks, Bevy async task, Bevy async ECS, PEX, Bevy jobs, and Bevy async runner are all listed. So there's a lot of people doing work for this kind of stuff. And I think like working on the lower level ECS stuff is where it is. Does that answer the question? You can also just go read the working group message, like the very first message in Discord. And then you can look through all the crates and things like that. There's a lot of discussion happening in there as well. But yeah, so like this async access function, like we said, is the point of the crate as far as I can tell. So this is pretty cool. So we have a system where we spawn a Tokyo in a certain thread. This is a spawn GLTF when ready system. So this basically just hands that off. This is equivalent. Yeah. This is equivalent to the observer that people want, actually. It's a little bit more verbose, a little bit more, it's much more verbose at the moment. But this is the asset loading async observer that people want, right? Actually. Like if you could wrap this up into a function and just call, yeah, there's nothing in here that actually depends on Bevy stuff. So you could totally just have like, I don't know, spawn Bevy task. Right? And then this is my task, and it takes world ID as an argument. Right? This could be this API here. And then you get your async function that you get to do whatever with. You get async access to do whatever async access you want. In this case, we do it in a loop. I don't know that this is like a wonderful way to do it. It works though. And then we actually get to kind of split this out a little bit. I feel like this is what I want to define as a function. So this async access accepts a tuple. I forget what the second argument is. What was the second argument? Async access. Second argument is func. So it's P function type out, right? So it's the query, it's the function type, and it's out. I think that this doesn't connect function and P at all, so we do have to indicate them separately. Well, P item here, actually. But this only really works for closures in that direction. I don't think it works the other way around. Ergonomics and efficiency are often the tricky bits. I wouldn't disagree with that necessarily. So this is just some random function then, right? In this case, we're returning control flow, but we could easily return like an option or something, or a result or whatever. So we end up with being able to, if we want to use this function repeatedly in a bunch of different places, we have to write this, which we could encapsulate in some small macro here like this. We have to write something like this, which kind of is like a generic function, right? This isn't really spawn GLTF when ready per se. This is reusable logic. This is this is run until break, right? And the function spawn GLTF here could also be an argument here, like run until break. The type for this would be what, func, where the output has to match the output of the async access. So theoretically, what, FN once we could do P item out. I'm trying to think about how to connect these. We could do P func out. Sorry, I saw a comment. If you could easily wrap any async function with an observer which executes your system when the future finishes. If you could easily wrap any async function with an observer which executes when your server finishes. Well, you can trigger an observer from within that async function. Right? So the ergonomics here are very much like, we want to pass this system in. This func we'll just call this F for now. This F is like this F, which is a little bit awkward. There's no bounds on this at all. This needs to take that as a type argument before we can use it. These types are not going to match up. We end up with for all fn once. Expected in fn once, found f, that's fine, I think. This needs to match though, so I think that we can just take this kind of a thing, right? But the question is, we don't have P, which is the system parameter, which would be this, right? So we basically need to like clone this function or clone this type signature where P is a system param static, right? If I can spell system param correctly. And this is for all func with 2 lifetimes. So something like this. And I haven't put, this isn't an aware clause, so I'm just kind of like futzing around here. Right, where P, this, F, system param comes in, F comes in, this is PF, out, so we end up like cloning all of these generics through to make this suitably generic. And then run until break can't infer that because things are now super generic. Yeah, so we need to specify this here instead, right? It's the wrong place to specify it. This is where I need to specify it. So we end up with control flow for out. Maybe underscore again if we get lucky. Plus this tuple. And we end up with just an issue with control flow because control flow needs to be unit. And then the question is, this is an output parameter of that function. So we end up with this being out, which is what we want. But if we don't specify this explicitly, and I think in this case we would want to, at least partially, right? So this becomes this. Out. This returns control flow. This doesn't exist here, so this is at least this. And then we have an issue with spawn GLTF, which is expected type parameter F found FN item. Okay, that's fine. Control flow should be on the function itself, not the generic. I assume that was a couple changes ago. The only thing left is FN pointer into. You already did that. I was just too slow. Okay, cool. Expected type parameter F found function pointer, right? Expected type parameter F, where F implements FN once, function pointers should do that. So the return type of the call is for all res GLTF, res commands to control flow. Do the type of the argument passed. We don't pass any arguments into spawn GLTF, right? This argument influences the return type of async access. So spawn GLTF, do we need to specify this in a different way? PF. And then this is expecting the third generic argument. It is control flow. It returns control flow. I'm not familiar with the internals here at all. This gets passed in to out. Func. Func is an FN once to out. Out is then only tied to this through the usage of nothing. Can you show the original code? You mean the original code that worked before I started messing with the generic function? Or... Yeah, I could do that. Give me a sec. I'm just going to copy that back, and then we're just going to go back in time a little bit. This was just kind of a fun thing I wanted to do anyway. Like it's not critical. I think this works. There's our cube. This is the code that works for the same area of stuff. And I can bring this into a larger screen and be like, this is the generic function that I'm trying to implement is kind of this. But something where I only need to define spawn GLTF. Control flow can be explicit. Because this is explicitly like return a control flow and this will run until you break. The last bit of the, I guess I could save this so that it actually types checks. Generic, right? Then we see our spawn GLTF issue here. So we end up with spawn GLTF needs to be replaced by the F param. Oh, thank you. Not using the arguments is absolutely one of the ways that you would, not get the inference. We do have a different issue, but I think that's fine. That is like such a simple. Hey, you didn't use the variable. Anyway. Value moved in previous iteration of the loop. I don't think we can clone this, right? I don't know that I want to clone this. Oh, that's the wrong place to put that anyway. Hang on. This is control flow FN once. Where's our FN once? Here. Okay. So that works. Yeah, it's because it's an FN once. Yeah. So with some type system shenanigans. This is okay. So for anybody who is not aware of what me and Florian were just talking about, is basically like we're passing through a bunch of the type arguments. So this system here is super generic, right? We can pass in pretty much anything we want to as long as it satisfies the parameters of what the callback needs. But because this async access has so many generics, we kind of need to thread those through. We thread them through here with basically the same constraints, except for the FN once being clone. And that means that we get to call this function like this, right? So we got effectively, if we want to, basically this is our call now. Run until break, system param, the func is inferred here, the world ID, and the system we want to run. And we could stick that in this like theoretical like little macro call here to spin up the runtime. So this could end up looking like spawn GLTF. You could wrap the F in a lambda and then call it. Then you could change the trait of F to FN or FN mute. You create a new FN once for every loop iteration that way. Yes, that makes sense to me. I don't think I'll do that right now, but I think that we effectively have created this API. Right. This could also be like this. This could be the entire call here. Like spawn Bevy task, handles the runtime, handles the spawn thread. We pass in run until break. We pass in our system params. We pass in the spawn GLTF. This is our spawn GLTF that will do the work. So we just need to, check the load state of the GLTF that we want to load and whatever, and then return our control flow. And we can actually make like a bunch of these functions, as many as we want, to do a bunch of different things. I don't know if that's particularly useful. I just found it interesting. Especially as an example of like this run until break function could now just be like hidden behind the Bevy Prelude APIs. So it's not like sugar can't be written. It's probably better if you're experimenting with this to go with the like full version and not try to over abstract, especially if you're not as familiar with things like FN once, FN mute, etc. Like Florian is saying. Cool. And then we get this GLTF, right? We have to get that resource because we have to care about something, et cetera, et cetera. We could probably throw more generics in there to be like, hey, you can pass in something that contains a handle. That we can then check if it's loaded or not, and then spawns it if it is. So like this could be a generic spawn default scene GLTF function or something like that. And then this also gets wrapped up, which is cool. So there's ways to abstract this stuff. What other use cases would we have here? I feel like asset stuff is definitely one of the use cases. What are we, 10 o'clock? Cool. I feel like asset server stuff is definitely one of the use cases because it's stuff that can happen on multiple frames. And then obviously you could send off requests to, I don't know, does Blue Sky have an avatar API? Right? Or something like that. So there are APIs for things like this. We're just thinking about like creating a demo that just loads in a bunch of Blue Sky avatars and then does something in Bevy with them. That would also be interesting. That's also pretty straightforward usage of this. I kind of can't think of anything that isn't very similar to this. Like, do this, check to see if the thing is ready, spawn. Or do this, check to see if the thing is ready, insert somewhere. I guess procedural generation is something that could go here. We do have that other demo that does landscape generation. I never moved that out into an IO task pool. Let's see, Rust Adventure, YT. The only downside of New Shell that I really feel like is it does new lines automatically for this stuff instead of like truncating the beginning of the file path. Terrain. Terrain. CD, YT, low poly terrain, Bevy. I did always mean to go back to this and shove it onto the GPU. See, do we do async? I don't think we do. This is basically just grab some noise, grab the wireframes, insert it on, modulate like a plane with a height map. So all of these queued commands could be async, right? And because we have access to everything, I think spawn terrain, and command for spawn terrain. Spawn terrain here does world access, grab some noise, basic multi-Perlin, creates a new mesh plane, so we would need access to the meshes database, does some modulation of the heights on that plane, inserts some color attributes, computes the terrain normals, grabs the mesh database, the standard material database, and a terrain store, which I think is a hash map, if I remember correctly, something like that, and then does a spawn. So this is a good candidate as well for that kind of thing, where if we threw this into an async task pool, because right now what's happening is basically these are running and we're limited by the amount of terrain that we can generate inside of one frame, right? And in this case, actually, we're queuing 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. We do have a little bit of a caching reaction here. So if we try to queue a command for terrain that already has been generated, we don't regenerate it. But here we queue 9 of them. And this could very easily be async instead, right? It's just commands right now. Which means that, like, if it gets pretty large, it will block. The other thing is we could do this on a GPU with a compute shader, and that would also be very async. This is just entirely self-contained, right? Let's do bin, and this is terrain. Dump this. Let's cargo run bin terrain. And this is older, so we need to update it a little bit first. Let's get rid of this. Let's get rid of these. Let's get rid of this. Bevy pan orbit camera probably isn't updated. Noise, we will just kind of replace, I think. So terrain store, hash map, Bevy collections, wireframe plugin. Why is wireframe plugin not? We'll comment out pan orbit camera plugin. This is our noise. This is our vertex attributes. Get single, I think, is just single now. Despawn recursive, this is already recursive. Pan orbit camera. Am I doing anything here that is actually worth continuing to do? Target focus. I don't think so. Let's comment this out. Sync camera to ship. Let's not run this right now. Render asset usage. And then the only thing left is noise. Right, so this is just a basic Perlin noise. So we can do NOIZ, which is my new favorite noise library. And they have a Perlin noise, I think, stock ready to go for us. So we don't even need to do anything special. There's no examples on the docs page, is there? That's really strange. Repository. So where's our noise? Oh, this isn't the one that I want. This is the one that I want. Let's do cargo add noise. And then we do want Perlin here. And they don't use it here, right? Perlin default. Funny that they don't use their own preset for that. There's like a ton of different kinds of noise. One of the reasons this library is cool is because it lets you build up noise structures based on the grids that they are. So noise is that, noise is insert resource, noise options, yada yada, seeded. There's a lot. Yada yada. Cells, curve, gradients. And how do we sample this? Random number from VEC, RNG. This RNG is noise RNG. Evaluate this with noise RNG. So noise RNG. And then evaluate. And this would be 3D Perlin. Is that why this is an issue? Cargo run bin terrain. Unsatisfied trait bound, gradient generator. Orthogrid partitioner is not satisfied. This is a noise function, produces F32s between -1 and 1. That's kind of what we want. This is what we want. This is the demo we want. Cool, so here's our noise, and then we do a get later, which is going to be this sample for, I believe. This sample for returns an F32. And this is going to be a vec2 new. I like that this is a vec2 rather than passing around like array slices. Unexpected closing delimiter. Those two. Oh, this, because I left some random code up there. This is not going to be F64s, so F64s can't go into this vec2. Arguments to this function are incorrect. That's correct. I think these are all already F32s, and that I needed to turn them into F64s for the other noise implementation. And mesh size times y. Y is the thing that needs to be actually converted. And then hopefully our camera's in A position. Okay, so we end up with kind of a flat plane there. This is going to be between 1 and 0, right? So let's do a debug here to make sure that the value comes out in some way that we would expect it to. This is going to be negative 1 to 1. And terrain height. It doesn't look like it updated the vertices. Like these heights are 13, 14. Did I mess up here? There we go. So let's make this not over. Well, we set the period, I think, actually, is what that's doing. So instead of doing the typical math you would do to extend the... Yeah. So I think the period we want is something more, maybe like 100. See all of these values that are getting generated. Kind of want... So realistically, we should be able to get an improvement in how much time this takes. Let's go for all these debugs and get rid of them. Make sure we're not using like terminal output as like the limiting factor on how fast our application is running. Let's get that camera movement back in here. Sync camera to ship, right? And this is just doing a target focus. So I think we just want camera here. I think we just want transform here, actually. So ship single. This is not orbit. This is going to be, I think we already have this. Orbit is result. Mute transform. Not really a controller. It's the, I'll just call it cam, I guess, since I already used camera. And we've got the ship translation. So we want to be, let's see, dot translation. We want to be in line with X. We want to be maybe 2 above Y and then 10 behind Z. We don't have any interpolation on the camera here or anything, so I think this will cause some issues, but or it won't because I'm not running the system. The number of times I make really silly mistakes like not using the function parameter or not running the system or not it tends to get high, especially later in the day. Okay. So we could afford to be a little bit further away from this little hypothetical ship. But here's our terrain in general. It's all vertex colored. So it's nothing particularly like amazing, you know? Cam dot look at ship dot translation vec3y. So here's all of that terrain and stuff. We could make this a little bit different. Every time it kind of like hitches here, right? If you can see the hitching, it kind of stops for a second. That's when it's generating. So I've already got this running in a way that causes a little bit of frame delay based on the amount of generation that we're doing. This is again running in dev mode. These problems can go away when you run release. This is unoptimized entirely, kind of on purpose, etc. But you can see all of the mesh, the wireframes, which is kind of cool. So with that in mind, we go back to our async stuff. Which I need to move to like the appropriate side of my monitor. Okay, so let's call this like terrain and terrain original, right? So now terrain is going to be the thing that we make async, hopefully, right? We need to pull in the plugin, so the async plugin. Let's do this and this. So we've got default plugins here. We've got default plugins here. This needs to be just inserted somewhere, so we'll just throw it at the end. Right, async plugin. This is going to be a spawn task, right? So the question here is, we're doing commands or queues, right? Command queues. So we're queuing these spawn terrain tasks. And I want to throw these, like we don't do too many of them. So I'm fine with just spawning a thread for each one, not doing anything too much more complicated than what we just did. But just throwing them to somewhere that is not the main thread, that it doesn't block our traversal here. So this is going to end up being something like this for each of these, right? And this is going to be spawn terrain with world ID. World ID is going to come from world ID res. We're going to pull it in from here. World ID res. Spawn terrain doesn't exist as a function, right? So let's comment these out for a second. Let's make this like all the way down here, some new function, fn spawn terrain. This is going to have to accept the world ID like we did before. This is going to do not this loop. This loop is not really going to be necessary. So we're going to do something like this inside of it, right? Access, await, we'll pull the access in, we'll pull the world ID in. We don't need the GLTF resource. We need the asset server. We don't need the GLTF stuff. We also don't need the control flow return type. This is going to be, we'll just call this like spawn terrain chunk, I guess. Right, and then this is async. And we've got fn spawn terrain chunk. Question from Alden. How has Bevy popularity been trending over the past year or two? You took a hiatus. Do we have a GUI editor yet? You're going to be very excited about BSN. BSN is coming in 0.18 definitively. Since you say that you've been out of the loop, I'm going to bring up the... I think we're calling this next generation in the PR that's up right now. Next generation Bevy scenes. So there's a whole bunch of stuff if you've been out of the loop for a year or two. There is a new set of experimental built-in like widget components. There's a whole bunch of new other things that I don't really want to list all of. But the big thing is going to be like there's work on an editor, which I would love to make a video on, but I need to clear some other stuff up first. There is no editor that you can download and install. So just to be clear, editor is still in development, but there's serious progress being made. The thing that we're waiting for at the moment, which is committed to for 0.18, which is going to be like a couple months from now, is BSN. And I don't know if you've been out of the loop for like 2 years, you might not remember BSN. But this is the effective idea here. So you have a player, it returns impulse scene. You have this BSN macro. There's also going to be an asset. You can do all of this. This is an observer. I think observers, you might be familiar with observers. If you're not familiar with observers, observers are great. There's a video on the channel to catch you up. This is going to be children, more entities inside of it. This is referring to sword by name, which also impulse scene down here. So this is sword. It also impulse scene. It has another number of components on this entity, so on and so forth. So with this, spawning hierarchies and scenes and overriding them and patching them and doing from world implementations for a whole bunch of stuff got a lot easier. And this is what the editor is being built on top of, effectively. You probably aren't familiar with relationships either if you've been out of the Bevy scene for a while. Looks nice. You were doing something like this BSN macro, but more manually. Are observers framework trigger wrapping the event system? So observers are the... If you're familiar with Bevy from 2 years ago, what you know as events are now messages, right? So your old event reader, event writer is now message reader, message writer. Observers are now events. I have a whole video on observers and component hooks on the channel. If you're interested in watching that, that will give you the full overview. But basically, observers are like observers and hooks. When you insert a component, for example, and it gets added, inserted, removed, etc., there are now component hooks that will fire immediately. Like immediately, such that nothing else can run between that component getting inserted and the hook firing. So they're really good for things like building indices. Observers are a more generic version of that system. So they can do all the component lifecycle events. They run just after the hook, but they can also do any arbitrary like user event. So you can like commands.trigger like mine explosion. Observers are particularly interesting for a variety of reasons, but they don't depend on the kind of like apply deferred thing that you're probably used to from 2 years ago. So you don't have to wait for a sync point for them to be able to do things. They run immediately, they run recursively. So if you have a thing that needs to happen, like a button click or a mine explosion or whatever, or you know, an index that you need to keep up to date, you can have an observer, which is just like a function. Lon wants to get technical. Yeah, so observers will run basically immediately after you trigger them. They will run recursively before anything else, and are very, very cool in that sense. So if you want batched events, you still want that message reader, message writer. If you have individual small scale events, people are using observers for basically everything right now. And Lon's comment is, well, observers are more like callback systems. Hooks are technically very different. Yeah. No, you're totally good. The stream is partially for people to ask questions. Everybody apologizes for asking questions, but the stream is for people to be able to like, hey, what about this? Like observers aren't an extension of hooks. The hooks also trigger an observer, but neither system really is based on the other. Yeah, I mean, if you want to get into the like upstream technical implementation details, yeah. But from the perspective of somebody using them, they both fire component lifecycle events. Observers are a generic version that you can add additional events into. So hooks only fire lifecycle events, which means that they are significantly more lightweight because they don't need to check to see if they need to trigger a user like custom event of any kind. Whereas observers can trigger any custom user event. Do I contribute to the engine? I do. So does Lond. This is IMO quite important because observers are generic event handlers and hooks are specific event producers. Why do you feel like that's really important? Right? Because from a user perspective, they both like fire events that you react to. Right? Hooks run first, observers run second, and observers have different use cases. But what is the important part there in your mind? And I'll I'll kind of let you answer that question because I'm sure typing speedily is not the best way to deal with that. Okay. Yeah, yeah. Because saying observers are an extension of hooks misses the point that observers have like two more ways to work and are not at all tied to a specific kind of event. I don't see how that misses the point there. Right? Hey, cappuccino, how's it going? Because like you can frame hooks as a very specific, very constrained version of observers. And I think that tracks mentally very well, right? And like in the same breath, I'm also saying that observers can do arbitrary custom user events and hooks can't. So I do mention that in the explanation that I just gave. I don't necessarily think it matters if somebody isn't aware of observers that observers can be targeted globally or at specific entities or at specific components or at an animation player, etc. Yeah, but listing off all the ways in which observers have more functionality doesn't, like, it's enough to say that they are an extension of hooks, right? Like observers have more features than hooks have. Is like the TLDR one sentence version of that, right? They basically do the same thing. If you're looking at just the component hooks, right? If you're just looking at just the lifecycle events, then hooks and observers do the same thing. But hooks can also do arbitrary custom user events and have more features, right? Curious about engine contributions. What's the split between issues that are complex and low level versus focusing on building ergonomics and dev experience? Split between API level versus engine internals. One of the really interesting things about Bevy is that if you're building a plugin in the ecosystem, that work is also engine work. So in the way that you would normally be like, oh, the engine is a completely separate application, isn't quite as true for Bevy. Because if you write Bevy code, you are writing the same kind of code that can live in the engine. So I guess like if you were really talking about engine internals, you might talk about ECS implementation. But my answer for like what people work on is what people are interested in, right? Like Bevy doesn't have a company. It only really pays Cart and Alice. Alice does quite a lot. Cart also does very deep work and quite a lot. But everybody else is kind of working on their own time on the things that interest them. So there's no like overarching split, I guess, in that sense. And Bevy as a community generally cares a lot about the developer experience and the ergonomics. So for example, you wouldn't have been around for this if you're just getting back into Bevy, but now hot patching exists. So you can do hot asset reloading, but also hot code reloading with Rust. It's not fully finished, There's some drawbacks. You can't do it in a workspace. But if you only have a main.rs, you can hot reload Rust code with your systems today, which is very cool. So there's a lot of focus on dev experience all the time. I think everybody really cares about, like, the Bevy community really cares about people being able to use the engine in general. Lond is, no, what I'm saying is that they're wholly unrelated and the approach of mentioning them together just gives the wrong impression of what they are. I really don't think it does. You suppose another way to put it is that by putting hooks first, it diminishes how general purpose observers are by priming people to think of them only in one context. So you would just not mention hooks then? Like, what is the answer to that? Because if you're talking about component lifecycle events, you have to talk about the fact that they can be hooks or observers, right? And the obvious lead-in is hooks handle component lifecycle events first and with lower overhead. And then you can also use observers, which are a more featureful feature, and then go into the other features. Like the hooks and observers video that I have, right? Doesn't stop at there are hook lifecycle components reactions and observer lifecycle component reactions, right? It goes into, oh, they're recursive, and oh, they can target entities, and oh, they can be global, and like it goes into all those other things. You think what is the optimal pedagogical approach, do you think? Because they share so many concepts. So, I mean, like, I'm very interested from that perspective. If you think there's a better way to teach it, I'm very open to hearing. Because I will have to make that video again, for example, right? Like observers will get more features. There will be another rewrite. I'll make that video again. You've never really peeped at ECS implementation. Always assume there's some auto indexing that happens on components, component groups, archetypes, yeah. Built dynamically based on the queries defined in systems. Not based on the queries in systems, but based on the components that are on entities. So archetypes are built from like the collection of entities that are the collection of components that exist on an entity as a group. That's a bunch of archetypes. It's not based on the queries. The queries do slightly different things. You've seen the Jarl dev talk about this in his Discord. Cool. I'm not sure exactly what they were saying, so I don't want to like confirm or refute anything, but if you're talking about ECS internals and you're talking about indexing and stuff, you're talking about like archetypes, which are built out of the like shapes, right? So if an entity has components A, B, C, that's an archetype. If a component only has B and C, that's a different archetype. There are queries that can like, I believe there are queries that are archetype level queries and there are queries that aren't. But that gets into some other weeds. You love that video, by the way. You've referred to it a few times. Very helpful. Sweet. I'm glad you find it useful. You can also use observers. Very different than observers are an extended version of that or something similar, which is what you said. Yes. I think also important context is I was responding to somebody who hasn't used Bevy in 2 years. So I'm just trying to give them the inclination that they should look into observers more than the full explanation of observers. Right? I think the audience for the video is different from the audience of somebody who is like, hey, I haven't touched Bevy in 2 years, just getting back into it. Like, what's going on? What should I pay attention to? Right? For the video, you would start with observers, show basic custom event usage, then go into a list of observer events, like picking and lifecycle hooks, and use that to segue to lifecycle hooks. I'm assuming you mean component hooks at the end there. The indexing covers all combinations of components, just a clever data structure. Like if I'm querying for a handful of components that might not be given. If you're querying for a handful of components, there might not be a given entity that has that exact archetype. Right, because you could be querying for a subset of components. Yeah, I figured that's what you meant at the end, component lifecycle hooks. Later. Have a good dinner. When you refer to the indexing, are you referring to archetypes in general? There are queries that will that are referred to as archetypal queries, and there are queries that aren't. So depending on the query you use, you are doing different things. Also, there are talks about automatically building indices. There have been talks about automatically building indices for a couple of versions now. So at some point there will be queries for that kind of stuff as well. You suppose your general context is there must be an underlying system to performantly query against all entities in the universe of things, even if it's a subset of components or components with specific state. Wasn't sure how lazy or exhaustive this was. It's lazy. It's extremely lazy. For example, if you set up a query, it effectively does nothing until you iterate over it. Right. When you have a query in a Bevy system, it doesn't build the whole set of stuff and give it to you. You have to iterate over it. So if you use a query, you can use that as like a database and do like query.get on like some ID, entity ID or something. And then you only get one item, right? You only get the results for that entity. You don't iterate over everything that ever existed. If you don't iterate, then you are not iterating. The same way that like iterators are lazy, in a sense. Let's see, 1054. Let's see if we can kick off this terrain before. Let's see, terrain all the way on the left here, right? Did I close out my terminal? No, I full screened it. Okay. So where was I? We are in spawn terrain. This is async access. We need to effectively replace this command, right? So this is all of the logic that we're going to do. I'm just going to copy this in. I'm going to comment this out so that we don't have this command anymore. And then this spawn terrain chunk is going to have to take in all of these queries. So what are we going to actually need? We're going to actually need, we've got the asset server, right? Also, since you've been out of it for a little bit, note that the stuff that I'm doing right here is doing some experimental things. Just to be clear about what's going on here. Okay. Spawn async function spawn terrain, async access. There's something wrong with this. Let's find out what it is before we continue. Maybe we comment out a decent amount of this code so that I don't have to see so many errors. Let's see. Spawn terrain chunk, we actually need to comment this out. So let's do spawn terrain. Let's mark this with a to-do because we're going to have to do that. We kick off all of our original spawn terrains and then we kick off them as we're moving through the world. And then this still has the errors in that query. So let's expected function that takes a single two tuple as an argument. Right. That is because I defined my function down here as this and not like this. I'm trying to do the destructuring. Cool. We don't need world here. This needs to be terrain store as a resource. So let's get res terrain store here. I think it does need to be mute. So res mute, which means this is going to be like mute terrain store. And this is going to be res mute terrain store. A little bit of duplication here because I'm choosing to write this in a separate function, but I'm okay with that. So terrain store dot zero dot get. And then are we capturing here? What is it that we're actually doing? We need to access a specific position and spawn terrain is going to get used here, block on spawn terrain world ID. This is going to be this IVEC. So we're going to accept an IVEC here in spawn terrain. This is going to be like chunk position. IVEC 2. This is spawn terrain chunk then, which I guess we can just pass the chunk position into, which then will like take the chunk position and return this closure. This is starting to look a little bit weird just because of the way I've decided to write it. Because now this is a closure anyway. Right? Let's comment this out. Let's get to the end here. I think we need another curly brace down at the end. This is that, this is that, this is deleted. So the question here is, what is the appropriate way to do this? I could stick the expected unit found closure. So like, this is going to have to be a type of like return fn once or whatever. I think we just stick this in a closure. I don't think that it's particularly worth doing all of this indirection for just the function signature. So let's start with commenting this out for the moment. This won't be spawn terrain chunk. This will just capture that variable. And then this is going to be asset server commands terrain store. What is the issue there? Res asset server, res mute terrain store commands. Oh, this is a tuple. This is the second time I've forgotten that this is supposed to be a tuple. Cool. And this is chunk position. right? So this is starting generation kind of thing. So then we need to start getting into what is the actual logic we're going to perform here. And in this case, it's going to be terrain store.get on this chunk position. And here we do is sum. We don't need that ever, right? Yeah, our logic here is just, you said you'd report back. So I got stepping to work using the eGUI example just from the 0.13 release page. It's more or less a drop-in solution. You posted these in the feedback channel on Discord. Cool. We don't use this chunk if it exists, right? If it exists, we just return. Dot is sum. Mesh already exists. Chunk position. This is a reference. So asset server commands terrain store. If this thing exists in the terrain store, we do nothing in return. Otherwise, it starts to get interesting. This is all the logic that we then need to do. So let's pull all of this in. And boink. Something went wrong with the... Did I copy an extra curly brace here? I think I did. Cool. So we've got a bunch of code that doesn't quite compile yet. We've got all of this happening in async access. I think there was a warning about overusing async access. So let me check the docs for this particular crate, which I got rid of. I don't know. I'm terrible about keeping my Chrome windows open. Like really, really bad. Docs.rs Bevy. Malloc async. Crates.io to read the README. I'm back. Sorry, I might have missed the last sentence you said about a combo. Oh, I just said have a great dinner earlier. Async access. So this puts us into the access world during that period of time. The question is, how much work do we actually want to do in that area? Keep closures short, do only the minimal work, reads, writes inside async access. So we aren't really supposed to eat the cost of everything. Right. So right now what I'm doing is kind of, we have the spawn terrain and I'm immediately running async access. But really I only need to check to see if like the chunk exists, for example. If the chunk exists, then we kind of just need to be done and return. Right. So chunk exists here. This returns true or false. True or false feel really bad. I think that it'll be okay for now, but I want to replace it. So let's drop this, and then this returns a bool, right? Input future output bool. So we await this. And then if chunk exists, then we return and warn. Otherwise, we start generation. So this whole section in here, positions, terrain height, mesh generation, all of this down to here. This is our next async point. So we don't actually need the asset server or commands here. We only need that terrain store for their first access. And then we need to do this access again down here, which is what our syntax is waiting for. And we need a paren to finish this off. Right? Square, terrain store. We're going to do more than terrain store here. There's also an issue up here. So a couple issues with self there. We can fix those. Async access, tuple, open paren, curly brace, await. Let's comment out all of the interior stuff just to make it a little bit easier to view. Oh, this doesn't return a bool because this isn't necessarily going to return a bool. Okay, so then we get, here we have world access. We don't really need world access per se. We need these two assets and the terrain store. So this is going to be res assets, res mute, right? Because we insert. And then this is going to be mute meshes, mute materials, terrain store. And this also has to be a mute terrain store here. It doesn't have to be up here. This can be non-mutable access because we're just doing a check. So we end up having like one check here to see if it's in the terrain store, right? See if the chunk already exists. If it exists, then we're just done, right? Task over. If it doesn't exist, we start generation. We do our per-lid noise. This has to be that IVEX, so it's going to be chunk position, X and Y. We get to get rid of a couple of these parentheses, which is great. Yada, yada, debug, colors, vertex colors, inserting them on the mesh. We've computed. Okay, so we've built our mesh at this point inside of our async function. We've computed the normals, and now we're ready to do another async access. So the next time the async access shows up, we are going to be adding the terrain, and creating a new material. We have our terrain store. So this is going to be terrain store dot insert. This is our chunk position. So we're going to need chunk position. And this is going to be probably commands.spawn. So we'll need commands here. Mute commands, commands. Mute commands. Out of habit, I'm writing it at like a query. So this should spawn as many of these as we want, not being blocked by the spawning. So we'll start it off with this situation. Unfortunately, let's just do the loop here for chunk position in, I don't know, some positions. We'll loop and we'll create these threads. And that means that we will get these IVEX to do our generation. There's a couple of extra parens, but we'll get rid of them in a second. Right? 3 parens down to 1 and a comma. So for chunk position in this set of positions, which I think this is getting upstreamed, which is really cool. I think we'll be able to do IVEC to like grid or IVEC to like cross and stuff like that in the future. So theoretically, this works. Chunk position here. We spawn all these threads. We should see terrain. If we see terrain, we've done a good job. If we don't see terrain, I have messed up in an unrecoverable way. That's a joke, but okay, so we are getting terrain, which is good. We will be able to get to the end here because we're not currently doing the on-demand generation, which is what we need to do next. So it's going to be the same thing. It's going to be the same little helper here. And we're going to do queue. Look for our spawn terrain queue. And this is going to spawn a thread for every chunk we need to render. We do need the world ID. So we need this here. Which will be this. This will be world ID. Chunk position is going to be chunk. So let's just call this chunk position. And now we should have async CPU-based terrain generation. So the goal here is to not see a hitch when we generate, which I'm not seeing a hitch. So we have effectively asynced our handling here, because generating these meshes as we're going through is not, just to give it kind of like a fine point, we can run the original. And if we start doing this, we end up seeing this huge hang up every time the terrain generates. I don't know how easy it is to see on stream, but it's like very obvious. Like that stoppage right there. Right? It's a little easier to see when we can see the terrain actually. Why not add the new FPS plugin with the graph? Because I completely forgot about the new FPS plugin with the graph. That's all. That's why. What is the new FPS plugin with the graph? I've seen the graph before, but is it FPS overlay plugin? Yeah, the frame time diagnostics. I think this adds that for us. No. Do I just need to default this? Nope. What is Rust Analyzer won't tell me what's wrong with my code. Yeah, it's FPS overlay plugin. Sweet. Dev tools. We don't have the dev tools enabled. That's what it is. I'm looking, so 0.18, I think will have dev tools enabled by default. I think. Or at least it'll be like a single feature flag. So we need to do Bevy version equals features equals Bevy. I guess dev tools is just all we need to do because we're doing it right here. Yeah. It's a feature flag. So you're telling me I don't need to add the plugin myself? I can just flip a feature flag? Or the dev tool stuff is a feature flag? There's a new feature flag that's just called dev for 0.18 that comes along with the whole new like 2D, 3D, etc. higher level collections. Cool. So while I'm here, I'll also add this to the original. So I guess let's start with the original and pray to hope that we... No, that's in 17 release notes. That's in 17 release notes. Okay, so let's start going. This is only ever going to hit 60 FPS because that's just the computer and monitor that I'm on. But look at that big red chunk. That big red block. Not the small one, but the big one. That's our frame rate dropping every time this generation happens. That's so cool to see. So if we run terrain, and I drop this into here, there's no big chunk. I don't know what's going on there. I've never seen that before. Keep in mind, this is also running in dev mode. But we're not seeing those huge chunks anymore. It's still a few frames, but it's amortized over 5 frames or something. You think it's still having an impact? I feel like we might need to use Tracy to figure that out. Right, because even sitting still here, there's something happening every couple of frames. Like that red right there is nothing related to us. I'm not really sure what that red is. The red we were seeing was a significantly bigger chunk. Dev with top level 3? Nope. We did nothing. We did literally nothing. This is an empty cargo toml. We can run dev op 3 though. If I can remember exactly how to write that. Bevy flock minimal cargo toml, opt level 3. And this should work for everything. So I guess let's test for original first, and then we'll do the other. No, please do opt level 3 for deps. We're doing it. It's happening. It's happening. Recompile time. Such is the life of cargo.toml modifier. Anybody, how's everybody else doing today? But yeah, back to your other comment about the hook stuff. You said that you would just do observers and then like mention hooks later at some point. I feel like that also matches a little bit with the way that they're used. So it's an interesting thing to mull over. Because most people use observers. Fewer people use hooks. Basically, everybody uses observers. Oh, you've been writing a Discord message because YouTube 250K? Cool. I will read the Discord message then, and we can kick that conversation till later. I think your thoughts are interesting. Is really all I have to say on the topic right now. Because for a variety of reasons. I guess I should occasionally mention that there is a Discord, right? I'm so bad at marketing. This is the Rust Adventure Discord. This is where I put all the streams. This is where I talk about all the stuff that I'm doing, et cetera, et cetera. My content is not sponsored. Rust Adventure is the only way that this gets funded. Did you see that somebody did a PR upstream to fix the on-demand mode for Tracy? The stuff that you kickstarted got people really interested. Dang, the ops level 3 really killing me today. No, wait, what? Go look at the Tracy thread. The one you posted. Somebody fixed on demand upstream. They submitted a PR. So exciting. Hopefully that PR gets accepted. I don't know if it will. I know nothing about how Tracy operates as a project. Okay, slightly longer message about hooks observers sent. Perfect. PR was merged already. Ah, the on-demand fix merged. That's sick. So active maintainership on the Tracy project is sweet. No 3,000 character message today. Mainly weird that by presenting concept like lifecycle hooks, event observers, custom observers, it sounds like the primary reason observers exist is to handle component lifecycle events, but that's a flawed picture. I see what you're saying. So like by explaining it that way, I'm not focusing on the higher level reason for observers. I'm focusing on the implementation details, and the implementation details, not upstream, but the ones that are like surface level, the way that you would use them are pretty similar, but that's not necessarily the important part about what an observer is. So maybe the next video drops hooks. Maybe I move the hooks to a different concepts directory. I don't know. I'll have to mull that over. Okay, so this is terrain original. Opt level 3 on Bevy. It's still interesting to see this little red bar repeatedly. I wish we had a longer... That almost doesn't seem like it's related to anything. That almost seems like a diagnostic collection issue. Because nothing is happening right now. Oh, people might click off after understanding what hooks are, thinking I don't need this when the larger part of the video is observer stuff. Yeah, to some extent. I'm planning on turning all of those concepts into like a full like Bevy workshop. So, yeah. The FPS could be an OS driver issue, possibly. I know Mac OS is not necessarily known for collecting statistics particularly well comparatively. And now the problem is, I think the generation happens fluidly, and we don't actually see any issues because we've optimized it. Part of the reason I was running in dev is because of that. Here's the new async version. That's a really great failure mode for that FPS counter. Can we get a view on that that's not that bad? Apparently not. Why is that FPS counter like just not happy? Well, there's literally nothing spiking at all in the async version. Maybe those little spikes are the terrain generation happening. Hard to tell. Either way, significant improvements from just making this async, right? Letting it go across frames, not bothering the main thread. And we're not even caring that much about like spawning these in green threads or anything, or like whatever. We're just letting them go. Not gonna lie, on Linux you'd use Mango HUD. I've never heard of Mango HUD. Why is the FPS fluctuating so much? What do you mean? Oh, you mean it like from 59 to 61 or whatever? I think this is like, you know, I'm actually not going to guess because I don't really know. I think it's a combination of Mac OS kind of not being great at measuring things, and Bevy giving you the exact Yeah. It's not smoothed, right? Because Bevy's giving us the exact FPS readout at any given instant. So like you can imagine that 59 low, 61 high smooths to 60. Especially if we don't have like dots, right? Like 59.95 or 61.02 or whatever. Your guess is that VSync over then undershoots the estimation for how long to sleep, but that's very off the cuff guess. Yeah. Like this is a 60 hertz max 4K monitor. It is not a gaming monitor. It can't run at 250. We will not get anything over 60, like realistically. So like it pinning like this is about as good as we're going to get on this Mac laptop, on this monitor. I don't know if smoothing is on the table for this widget. It might be helpful, especially, it might be helpful if I smooth when I'm doing demonstrations. I don't know if it helps people actually doing work, but yeah, we're not using frame pacing or anything. I hope frame pacing gets upstreamed at some point. That would be very cool. Frame pacing not currently upstreamed, but is a third-party thing you can use. Anyway, the point being, making this async terrain generation really helped a lot. There's effectively no whatever. Of course, disable vsync for benchmarking. Yeah. So I'm hyped on that. I think that's enough demos for async stuff. We spent like 3.5 hours doing async stuff. Granted, the first 2 hours was me figuring out what exactly the crate was supposed to be. But this works pretty well for just offloading some like general CPU compute. Guess we don't need this spawn terrain anymore. Is there a terrain size variable that I have somewhere? That's another question. Transform, chunk position, chunk size. Can we just like add a 0? Again, I'm still running in dev mode. I kind of just want to see it like delay a little bit. Yeah, so there's the delay with an extra 0 for the terrain generation. There's no issue with like my actual little thing running around, right? Like we can still work all of this stuff together. Did I do something silly though? Here's another question. I didn't do any ending generation, did I? 1, 2, 3, 4, 5, 6, 7, 8, 9. Did this even trigger? Or is it... The other thing is if you click off a Bevy application, it goes into like, I don't want to say sleep mode, but it reduces the frame count. XZ chunk size. See if we can trigger another one. My guess is actually that I didn't trigger this because I'm triggering on an offset from some other number that I hard-coded. So this chunk size is for positioning stuff. And then when we do the generation, the mesh size. So if I make this 10 and I make the other one 10, these two should be these should be the same number. I think we might have to boost the travel time distance of this little cube. Because we're effectively moving so slow. See if the terminal will tell us when we spawn our next trigger. There it is. So no impact. Generating another 10,000 sized meshes. So in any case, very cool stuff. The async access is very cool. I might actually end up using this. It explicitly is said not production ready, but you know, who knows? Maybe I'll just do some stuff. Anyway, I think that's it for today. We're almost at noon. Next stream will be Monday morning. So no stream Sunday, Monday morning. Monday morning will probably be more Rust language stuff. I'm hoping to get a whole bunch of that scripting done this weekend. So we'll see. But thanks everyone for hanging out, and I will catch you in the next one. As soon as I find all the buttons to be able to hit